So now we've arrived at the subtract from 10 strategy, but truly what it is about decomposing the number 10. If our students know all the combinations and pairs of numbers that can make a 10, we can relate that with inverse operations of addition and subtraction to be able to know that if I take one pair or one of the pairs away, it leaves the other. So lots of concrete, pictorial, and abstract things we want to be able to do with the kiddos with that. One great way to start here is do a part-part total, Matt. I know it's usually called part-part whole, but I heard Greg Tang recently talk about having it be part total, and I really agree with it because the whole always means a fraction to me. So I like the idea of a part and then making a total. So we can begin with having our mat with having 10, let's say, cubes or any kind of concrete objects that you want, and then we can just separate them out, and some can make it to one side and some can make it to the other, and then we can be able to record that as an equation that we had our 10 and that we broke it apart into the 4 and the 6. But of course, if I had my 10 and I took away the 4, it leaves the 6, or if I had my 10 and took away the 6, it leaves the 4. So being able to act that out and be able to see that on any kind of recording mats is a great idea. Similarly, if we had like a number bond, having our whatever number, we want kids actually be able to decompose from any of the numbers from up to 10. We're going to need that as a strategy in our Bridge 10 strategy later. So if we have our whole amount here, we've got our 10. Again, some can make it to one side, some can make it to the other. And then we relate that to the 10 take away 8 leaves the 2, and 10 take away the 2, it leaves the 8. As we progress, we also can do a hiding game so that once the students are familiar with the pairs of numbers that make the 10, you can have them have 10 objects. You can do this in partners as well. And then you take a cup and then you hide some of them so that if you're hiding one of the parts from them, and we know that there's 10, so if you determine ahead of time there's 10 and nothing's going to be added or taken away, nothing's going to be able to be there to trick them or anything. And then they're able to see that they have the 6 here, then they can determine how many are in the under the cup. And then they can see and get that instant feedback right now to see it. So that's a great opportunity in centers for kids to work on that together. And then, of course, they can record the equations that go along with it. Another great idea for this decomposing 10 would be to take two-sided counters, and then you can just shake them and drop them. And then you can be able to see how many turned out to be yellow, how many were red, because, of course, 2 that are red and 8 that are yellow is different than 2 that are yellow and 8 that are red. We want the students to be able to understand that commutative property of addition. So what you can do is you can have a recording sheet of all the possibilities of the combinations of making 10, including the ones that have the opposite, the commutative property where 2 are red and 8 are yellow, and then 2 are yellow and 8 are red. And then they can record those. They keep doing it over and over again, getting that practice. They can see which possibility, which of those situations happen the most, let's say. So they get lots of practice doing that. With those, a lot of fun things like split machines. So you can make a split machine for any of the numbers up to 10, but then you have the number of beads up on top that match the number of the split machine. And then your students can be breaking it apart. So you can say, okay, split. And then put some on one side and some on the other, and you talk about what are the possibilities. Oh, I ended up having with 7 on the left and 3 on the right. Remember, we want to color code the benchmark of the 5 as well, so they can always be using that benchmark of 5 to help them. So that's one way that we could talk about all the possibilities. Another idea is a number bracelet. So this is a good kind of hiding game for kids to do in partners as well, where we know this beaded bracelet has 10 of them on it. So if I hide something under my hand and you're seeing the amount over here, how many are under my hand, we're able to see, that it is that one. So lots of great ideas there for those kiddos to do in like groups. Then we have the Rec and Rec. I love the hiding game of the decomposition of hiding games. So I'll tell the students, I want you to move over 10 beads in any way that you want to, and you can use both rows if you'd like to. So students can understand and know that they can do it any way. So then I might slide it over in one way. Let's say that I do 1 and 9. And then the students would slide it over, and then they would try to guess how I did it. Now, I want active engagement from the students, so I always have them, if one person suggests, well, I have 5 on the top and 5 on the bottom, I say, nope, that wasn't my way. Everyone try another way. So they're all constantly having to think of all the different pairs of numbers that make up that 10. And then we can relate that to the taking it away from a 10. Another favorite way for me is the Cuisenaire rods, because Cuisenaire rods are able to help us show so many different things. They're just the most versatile math tool Now, here's a way that I can systematically find out all the pairs of numbers that make up the 10. So I begin with my 10 rod, and then I have my 9 and 1 and 8 and 2 and 7 and 3, 6 and 4. Here's where I point out that the students, that a 10 must be an even number because I see a doubles fact. And even numbers are numbers that can be divisible by 2. So when I have a doubles fact, I know that that total number must be an even number. So when I see that, I kind of point it out to the kiddos as well. But here we can see how now the community property has kicked in because my 6 and my 4 here turned into the 4 and the 6. Okay, it's a different situation. Contextually, it can be a different situation as well. We put this in context of a story problem where both add-ends are unknown. It's a different situation, so you want students to understand that. But they also can see with these Cuisenaire rods the underlying structure and pattern we have going on, that it's one taking away one from one add-end and giving it to the other. And once we know we've gotten down to the same rod again, I know I have all the possibilities. And so I've systematically done that. When students begin randomly guessing different pairs of numbers, they have no guarantee that they found them all. So I do love to be able to have that. And then be able to use the Cuisenaire rods, of course, to even just show what's happening here. So let's say that I showed an example of a 6 plus a 4 equals a 10. I love how they match up exactly to a tape diagram. So I love using these to explore word problem types that involve addition and subtraction as well. So I can see if I have my 6 plus 4 equals 10, well, I know that the 10 take away the 6 must be the 4, and the 10 take away the 4 must be the 6. And because the Cuisenaire rods allow us to show the children these amounts existing as a group, they're not having to count by ones. They're not constantly counting and seeing it existing as one. So I do love the power of those. Now, moving on to Pictorial, anything we can do to kind of help the kids visualize what's happening with the 10. I love 10 frames. And so you can just do a quick image. You can show that to the kids and then take it away and say, okay, how many would make the 10? Make them make that visual image in their brain to know that it's 8, and then it takes 2 more to fill that 10 frame. So any of these kind of 10 frame flashcards that we can use are fabulous. We also can play games that are, let's say, Go 10. So you're playing Go Fish, but you're playing Go 10. So I'm going to ask you for the pair that makes a 10. So if I said, let's say, if in my hand I had this card of the 7, I would ask you, do you have a 3? Because 7 and the 3 make that 10. So that kind of go, and again, I love using subtitling cards as well. These are Christina Tondevol's from her buildmathminds.com site. But I love these because they're all different ways of representing the amounts and not just the digits. They're very abstract. And one last way that I wanted to show you, this is one of my favorite games. It's called Birds and Worms. So you can, you roll these 10 dice. So I like it in the dice form. So you roll it, these 10 dice, and then you try to find combinations that make a 10. So if I have 7 and a 3, oh, that makes a 10. And then I have, and you can do any combination of the cube. So 5 and 3 make 8, 2 more make a 10. And then I have, let's see, 6, 7. Oh, I have another 10 here. So in this case, I would have rolled, I would have made 3 combinations of make 10s. I would have scored 3 points. And we call them apples because within this game are birds and worms. So if I happened to have, let's say, rolled a worm, then a worm could eat one of my apples and I would not score a point for that. But if you were to have rolled, let's say, a bird and a worm, the bird would eat the worm, rendering it useless. So I'd be able to score my points. So the idea is you're going to shake all of these 10 cubes. So every student rolls all 10 at the same time. Uh-oh, I have 4 worms. So what, well, although I do have 1 bird. So the bird would cancel out this worm. But I've got 3 worms here. So whatever combination of 10 that I would make, they're all going to be going away. So, and you can choose to end the game whenever you'd like. It could be the number of points, first person to get to a certain number of points or a certain time limit. It's up to you, but you can find this game. I've written out the protocol, both in a card version as well as this dice at the protocol for making the dice on the Padlet of the Math Running Records website. And yeah, so that's really, really fun game. The kids love that. So all we can do to explore to decompose a 10 will help us in that subtraction strategy of taking away from a 10.